Okay, so I have probably the most challenging, or if not one of the most challenging problems in the section 7. This is the same as number 20, and it's involving current through a certain element in a circuit, but the differential equation is not equal to just some number where we can use the method of undetermined coefficients or change in parameters, variation in parameters. We have to use a step function because we have a piecewise function. So let's get into it. We have I double prime t plus 9it is equal to this piecewise. First step is to convert this piecewise into a step function. That's not too bad. If you'll recall, it's 48 sine t times u t minus 2 pi minus u, or sorry, 0, t minus 2 pi's over here. And then you'll distribute that 48 sine t, and you'll be left with 48 sine t u t minus 48 sine t u t minus 2 pi. So now what you want to do is you want to take the Laplace transform of both sides. So if you'll recall, I double prime is, or the second derivative function is y of s squared minus the initial condition times s, which is just negative s in this case, minus I prime a 0, which is minus 24. Okay, the Laplace transform of just function is just y of s, so plus 9 y of s. Now let's take the Laplace transform of this function. Well, if you'll remember, the Laplace transform of a function is the Laplace transform of the function of t plus tau times e to the negative tau s. Well, in this case, we're not subtracting by anything. It's t minus 0, right? T minus 0, e to the tau will just be e to the negative 0 times s, which is just 1. And t plus tau, or t plus 0, is just t. So we have to take the Laplace transform of 48 sine t. And that's just 48 over s squared plus 1. And now, similarly, we have negative 48 times, well, the Laplace transform of this is e to the negative tau s. Well, it's 2 pi is tau, so e to the negative 2 pi s times t plus tau. Well, it would be t plus 2 pi. T plus 2 pi, or sine of t plus 2 pi is still just sine of t. So we're going to end up with s squared plus 1 here. But it's important we keep these two separate because this is multiplied by an e to the negative 2 pi s. So it implies that this part is a step function. So that comes into play later. But for now, let's just move on. We're going to do our usual thing where we factor out the y of s, and we'll be left with s squared plus 9 is equal to, and we're going to add the s and add the 24 over. So we're going to get 48 over s squared plus 1 minus 48 e to the negative 2 pi s over s squared plus 1, and of course we're going to have plus s plus 24. But remember, we want to keep these separate. But we also, our end game here is going to try to set up a partial fraction. So we're going to combine these terms with this by multiplying all these terms by s squared plus 1. and putting them over this so that s squared plus 1s would cancel. Your common denominator, just basic algebra. Then we're going to divide by s squared plus 9. So we're going to end up with y of s is equal to 48 plus s times s squared plus 1 plus 24 s squared plus 1 squared plus 1 over s squared plus 1 minus 48 e to the negative 2 pi s over s squared plus 1. And remember, we divided this s squared plus 9 over, so we're going to include that here. So now we've simplified this into two parts. A part with all terms that aren't multiplied by e to the negative something s, and a part that is multiplied by e to the negative 2 pi s or something s. It doesn't matter as long as it's multiplied by a negative s in your example. That's going to be the step function part, and this is going to be the non-step function part. And we're going to find the partial fractions of these separately. So I've done that math, and when you do that and you set these up, you're going to find that a is equal to 0, b is equal to 6, c is equal to 1, and e is equal to 18 up here when you set it up like this. And again, it depends on your problem. But this is just a standard partial fraction. This one is the one with the e to the negative 2 pi s, the step function part. And the important thing to remember about this is you kind of just disregard the e to the negative 2 pi s and solve it as if it's a regular step function. And that's fine until you go to solve the inverse. So I'm gonna rewrite this here. So we're gonna have b, which is 6 s squared plus 1. C is 1, so s squared plus 9. And e is 18, so 18 s squared plus 9. This is the partial fraction for this part. Now the partial fraction for this part is let's see here. I've been screwing this up. Let me just double check here that I got the math right. But that's not the problem. Oh, here it is. So I just see I got the math right here. So we're going to have b is equal to negative 6 when b is equal to negative 6. No, b is going to be positive 6, and e is going to be negative 6. I screwed up the signs there. So we're going to be left with 6. So plus, this is all going to be in parentheses because this is the unit step, or the step function part. It's going to be 6 over s squared plus 9. Minus 6 s squared plus 1. And when you do that, it's going to be multiplied by e to the negative 2 pi s. And this is where this comes in when we find the inverse Laplace transform. So these inverse Laplace transforms aren't bad. This is going to be 6 sine t. This is using the chart from the first section. This is going to be, this will be, well, let's see here. That's b, right? C is s. Oh, yep, this will be cosine 3t. And this will be, remember, there needs to be beta up here. Beta's 3. So 3 times what will give you 18? 6 will give you that. So 6 sine 3t. Plus, this is where it gets tricky. Not this part in particular. This is 3 sine 3t. Because we need 3 up here. Oh, sorry. This is going to be 2. Sorry, 2. 2 sine 3t. Minus, that's going to be 6 sine t. Yep. But we have to include this unit step function. Well, the unit step function is just u t minus 2 pi. And that's because it's e to the negative 2 pi s. So you multiply this unit step function term by u times t minus 2 pi. And that's the answer. That's actually the current through the element at a certain point. And it was a challenging problem. Like I said, we had to know how to find the unit step function, or the step function rather. We had to find the Laplace transform. We had this pretty difficult partial fraction. And then you finally get to the new material, and that's how to take an inverse Laplace transform of a step function. And to do that, it's actually probably one of the easier parts. It's you just multiply the step function part times u t minus whatever tau is. And that's how you get this answer. So like I said, this is a difficult problem, but if you understand it, I think you'll be in good shape for the chapter up to this point. Best of luck.